And welcome back. Now on the workbench today you can see these 4 digits which are in fact just controlled by a shift register. We've covered that in previous videos, but that isn't what this is doing here. This is a clock and it's accurate within, well, a few microseconds every day. We can tell when it's going to change just by counting down. 3, 2, 1, go. There we are, look, spot on. How does that work then? I'd like to give a big shout out to my sponsor PCBWay, PCB prototype the easy way. Let's have a look at their new Superior A+ Advanced PCB. Here you can find all the details of what their advanced PCB service consists of, and there's a handy comparison table to see the benefits of the advanced PCB service. Scroll down to the PCB showcase and you can see some examples of what they can do for you. Just go to their easy online PCB instant quote page and select the advanced PCB option. Simple. If you have advanced requirements for your PCB, try PCBWay. Try them now. Yes indeed. Now there's my wristwatch that I synchronized this one to. Well, you know, and when the second hand hits just 3 seconds before the 12 o'clock, that's when the animation for this shift register controlled 4-digit LED starts to work. About now. There we are, look, there it goes, you see. Yeah, so basically this was brought about because somebody commented in the previous video when we talked about shift registers, like, oh, maybe that bitwise walking of the individual bits could be quite a good animation for a clock, or would it get annoying after a while? And I thought, I wonder what you could do then. How do you make it shift down and keep the same value without it looking a bit of a mess? So I thought, well, I'll just have a go. So I did. And yeah, he was right. It was a bit of a mess and it did get a bit annoying. But the animation that you just saw there would, in fact, I believe, work for a bedside clock at least. But more importantly, while I was doing this, I thought, well, we already know that trying to make some kind of accurate loop in an Arduino for clock purposes is just a non-starter. It just doesn't work. Hang on, here we go. 3, 2, 1, off you go, clock. There we are. Look at that. See, accurate. So I thought, what can I do? Are there any timer task bits of code out that I can quickly snuffle and stuff in here? And this is when I came across this task scheduler, and it's just that little bit better than most, I guess you call it. It's obviously a very sophisticated task scheduler. But what? No. This isn't like RTOS. Well, I suppose it must be a little bit. But it's, yeah, that video there that we did about running free RTOS on the Arduino is similar, granted. But this is simpler. And you can just run tasks, I mean as many as the Arduino will support anyway, and you can have different attributes to those tasks. Like, for example, this one, you say, I want this one to be ultra accurate. That is, I've said I want those digits to change every minute. Okay, there it goes. And if it gets out of sync, it says, well, I'm a little bit behind now, so I'll just catch up and make sure it really does get executed once per minute or once per second or whatever interval you've put in. All right. Okay, just before we move on to the code, I've actually changed the code. Yes, I thought, well, hang on, if we've got a task scheduler, I suppose I really ought to have more than one task, shouldn't I, just to show you it's working. So I've added in this other task down here that flashes once every second. Well, actually, that's not true. It flashes twice a second, doesn't it? It flashes on, then it flashes off. So that's on, off, half a second each time. So that's 2 hertz, yeah, 2 cycles. But anyway, that is a separate task to the task that's controlling all the digits at the top, just so that we can see that in the code. So we're just going to whiz through the code pretty quick. I'm going to ignore all the stuff that's talking about the HC595 at the back there, because we sort of covered that. And I was only doing this for a bit of fun, just to see that animation as it changes on the minute. Yeah, I think there's probably more you could do if you really wanted to make a bedside clock with this sort of display. I reckon A, you could now do it because this is accurate enough, and secondly, by tweaking those individual digits with the load line, yeah, as you transfer the value from the register to the actual digit so you can see it. By doing that independently, I think you could have quite an interesting display for very, very little cost. So a nano plus those digits you see there would probably work. Okay, the worst thing about this, of course, is that there's a huge gap in between because the board that they're on just was never designed to cascade properly, you know, to basically butt them up like that, or to have a tiny little gap where you can just have a colon in the middle. But I guess you could make your own board if you're really that interested. But let's have a look at the code now for the task scheduling. Okay, this is the sketch, and as I said, I might have said before, it might be on the cutting room floor, I was using the Arduino 2.0.0 IDE. It's just released, it's now out of beta and into proper production. However, this is now not Arduino, this is now my Platform.io, which looks very similar because the underlying code is the same as for the Arduino 2.0.0 IDE. It's very similar because it's all based on Eclipse, but we're using Platform.io, as I say, just because A, I'm more familiar with it, and there's a couple of things I want to do. So let's whiz through this. First of all, okay, yes, I have to put this include Arduino at the top because well, it could be anything, couldn't it, really? Arduino is just one of the many platforms that supports. Charset, forget that, we did that last time. It's just a little tiny file I've written for the binary implementation of those digits. Yes, I am using libprintf. What? Yes, that's right. It's that video there that we did a little while ago. Libprintf for Arduino. Absolutely brilliant. I'm using it here because I get sick and tired of having to write multiple serial.print statements when I just want to print it all on one line. So you'll be seeing that in here, the use of that. Okay, so do it. Yeah, do it. Go and download it, watch that video and just see how brilliant it is. Right, now we're defining some options here before we include the task scheduler library. Yeah, I'll tell you where I've got the library from. It'll be in the video description down there, okay? But we need to do all these defines, if you're going to do them at all, before you include it, because there's, you know, if statements as part of this. So I'm saying, look, I want to tell you about some options that I want, and we'll come on to those. All this here, digits, clock pin, blank, all that's part of the digit implementation that we've already covered. There's my new second counter, right? It's just on pin 13, which means you don't even need an LED because it's the built-in LED on the Arduino Uno board. Fine. That's when I started up 1030. Right. These are the functions that we're going to be using as part of the task scheduler, and you've got to forward declare them because if you look at this line here, we'll just skip over that one for a minute. We're saying, look, I've got a task and I'm calling it clock task, and I want it to run exactly every 60,000 milliseconds. In other words, every 60 seconds, right? So every minute it'll fire. I want it to run forever, and this is the task that I want you to run. This is the callback. So at the end of that period, I want you to fire off this particular function. And he goes, what function? What? I don't know anything about that function. That's why we have to declare it up here first. Okay. Now, whether the Arduino IDE... No, the Arduino IDE doesn't allow that, actually. Normally, the Arduino IDE is very forgiving about forward declarations. In fact, it whizzes through your program, finds them all, declares them all up front, behind the scenes for you, and then compiles, so you don't get any of this I don't know what you're talking about messages. But in this particular instance, we do need the actual task function that you want to run declared like this. So it's just exactly the same as whatever function you've actually written without the body. Okay. If you're hearing a slight tinkling bell, that's the cat collar. Yeah, that one. She's scratching. Right, so this is the second task. So I've got one called seconds task, and I want it to run, as I say, twice a second, so every 500 milliseconds. So it's firing twice a second, but once to turn off and once to turn on. So we get the turn on of that LED every second. Okay, and it's exactly the same as the first one. I want it to run forever, and that's the name of it. And I'm going to declare that up here. Fine. Setup, okay, all these pins are output pins. That's from the HC595 from last time, plus the LED one. Yeah, we know all that. Fine. Okay. This is the interesting bit then. So we're saying now, look, my clock task and the seconds task set scheduling option. And you can only do the set scheduling option if right at the top we've included this bit here, task scheduling options. All right, if you don't include that there, it goes, I don't know what you're talking about. So bear that in mind. So the scheduling option is task schedule. Now what does that mean? Right, task schedule means I want this to be accurate. So if, as part of scheduling that task, and I'm guessing because I haven't looked at the code and I don't want to either, I'm doing this as a consumer of this library. If, as part of scheduling this task, you're giving those tasks a certain amount of time, and you notice that one's starting to drift a little bit, you know, we haven't done quite enough tasks. If we're saying we want to do this every, let's say every half a second, yeah, like the flasher, but there's a drift because the task is a little bit long running, maybe it will catch up. So it will ensure that it does actually execute the right number of tasks in any given time frame, which is why, obviously, that clock on the workbench is super accurate, because it really is ensuring that every single minute on the dot it's firing and it's not losing seconds or whatever. Now the two other options on here, which you can see in the examples, one is I don't care, just run it pretty much every second or minute or hour or whatever it is you're going to do, and if it's close enough, it's close enough, not worried, fine, okay. And a lot of tasks like that, a lot of tasks do not have to be that accurate. Just fire it, run it, and do it again in, you know, 5 minutes or something. And the other option is to say, yes, I want it accurate, but in a different way. I want you to fire the task and then 5 seconds later, fire it again. But it's always from when the last task started. So it will keep the 5 seconds going, but of course there could be drift overall. Yeah, it's subtle, but it really does matter. So you really need to look at the examples in the library for this and just see what options there are and things. In fact, if we execute an F12 on there, F12, what did I press? No, it's not going to do it, is it? That's because my keyboard is switched off. I'll tell you, you can't make these things up. Can you hear I'm in the middle of a video? My keyboard, it's supposed to be running on internal batteries now because I've disconnected it. Here it is. It's a Corsair, by the way. Yeah, it's switched off. How can it do that? Let's switch it back on. Right, it's back on now in wireless mode. Right, okay. So let's have a look at these set scheduling options. Here we are. Okay, that's defining them. That's not really what I wanted. I wanted here, this bit. So these are all the options you can state as part of that task. Whether it's time critical, for example, sleep on idle. Oh yeah, that's the other thing I do. If it's scheduling all these tasks, but there's nothing to run now, say it's scheduled, you know, 3 or 4 tasks, and it goes, well, that one's due in 50 milliseconds, that one's due in a second, and so on. I've got nothing to run. I'll go to sleep. Saves power. On the Arduino, and if you're not on battery, I'm not sure it really matters a great deal, quite frankly. I mean, you make your own mind up on that. If you're running a battery-powered project, absolutely, that's when this comes into play, doesn't it? Even a millisecond of sleep will save you power on a battery. Believe me, in the last 12 months, I've made lots of battery-powered stuff, and those seconds really do add up. You know, well, milliseconds add up, and can save you an awful lot of power, and your battery will last, you know, another month or 2 or 6 or whatever. So yeah, that's quite interesting, and I'll probably have to have a look at that myself, actually. Anyway, there's all these tasks that you can see here, and I haven't really looked at a lot of these yet, but because I wanted to bring this to your attention. So yeah, you can have a look at that yourself. Right, back to the main code. So we've set these scheduling options. Now we're saying, look, the schedule that we did in fact skip over, didn't we? We declared it up here. We just said, look, there's a schedule, right? There's no detail on it. It's just a schedule. What we're now saying is initialize it, add the 2 tasks that we've defined previously, yeah, and enable the tasks. If you do not enable the tasks, they will not run. Okay, when I first did this, I didn't enable that LED flashing task. Nothing happened. I thought, what's gone wrong? Anyway, quick fix, done. And well, that's that. And in the loop, the only thing you have to do is say execute the schedule, and anything else you want to do in the loop, of course. Yeah, so your loop can consist of whatever code you want plus schedule, execute the schedule. But of course, remember, if your loop is long running and takes longer than, say, 1 millisecond to run, which is an awful long time in computer programming terms, things might get out of step, which is why those catch up options are so very useful. My loop, though, as you can see, only does the scheduling, so it's not surprising really that it keeps things in line. Right, so there's a couple of other things here that are just to do with the HC595, which we covered in the previous video. This is my callback for the clock task, though. So when it comes in every minute, it says, right, work out which are the tens, which are the units for the hour, which are the tens and which are the units for the minutes. So we've split them up now into individual values for the digits. A little bit of debugging here. Now this is a good example of the printf, look, where you can say, look, you can print all these things in one line. So I can say tens, and then there's a decimal value here, units, decimal value, decimal value, decimal value, and then tell it what the decimal values were that I want displayed. Great, isn't it? I mean, it's really, really, really useful. That would take, I don't know how many serial.print statements that would take. Too many, that's for sure. And then I'm just sending out the actual individual digits to display the time on here. Fine. Right, then I'm just saying, well, okay, if the minutes have overflowed now, update the hours, and if the hours have gone beyond the end of the day, update that as well. Fine, that's not a problem. And then my seconds toggle. So basically what it's saying is, every half a second, as this is fired by that task scheduler, on that LED, output whatever it isn't now. So it has a digital read of that particular pin and goes not. That's what the exclamation mark is there. So not whatever it is now. So if it's on now, make it off, and if it's off, make it on. Pretty easy and straightforward, isn't it? And avoids an if statement and all that kind of stuff. So you can see it's all pretty straightforward, this, isn't it? Now I'm going to put all the details of that library, the task scheduler library, in the description below, and there'll be stuff up in my GitHub as well. Do go and have a look at the GitHub, because all the sketches will be up there that you can just download and run or whatever, and you can take out all the stuff for the HC595 if you don't want that, and just do a display to your debugging window, the serial monitor. Yeah, that's pretty easy. So let's just have a very quick look at the GitHub for that library, not mine, that library there. Right, this is the GitHub where he's put his library. This is Anatoli Arkhipenko, that's his name. There it is, Anatoli Arkhipenko. He's in Brooklyn, I think, isn't he? Yeah, Brooklyn, New York. Yeah, I know, that wasn't a New York accent, was it? No. So that's where he's put this, and the examples are many, and I was going to say complex. That's not the right word. They are quite detailed. So you need to look at the examples to decide what sort of function you want to carry out. And there's too many here for me to go into, but they're definitely worth a look at the code. Yeah, he does cover quite a bit though in some of the examples. You have to sort of read through it, but it's worth it. Believe me, if you're looking for a task scheduler on your Arduino, which you should be, because it avoids all that spaghetti code, doesn't it? You know, one thing calling another, and if this, then that. Yeah, I know. I'm as guilty as everybody else, saying, you know, if a certain number of milliseconds has passed, run this, and if not, do something else or do nothing. This way, we can avoid all that. Yeah, we can just say, task scheduler, run this every so often. The end. Never have to think about it again. You don't have to look at your code, nothing. It's just, you can put the code, in fact, into a different file then, can't you? And it's out of sight, out of mind. It just does it. Yeah, I know. I shall be exploring this quite a bit, actually, yeah, because it's a nice step up from standard coding, using millis to determine whether you're not going to run a function, but less complex than the RTOS stuff. Yeah, that stuff, the RTOS, which does take a little bit of space in your, especially in Arduino. Be all right on a Mega 2560 because there's a lot more space, but Arduino, it's a little bit tight, isn't it? Yeah, a little bit tight. But this hardly takes up any space at all. So yeah, it's definitely worth having a look at this. Now, Anatoli does say, as part of the GitHub, this is just scroll down a bit, a little bit of documentation here, a summary really, about what it can and can't do, and yeah, and updates and stuff like that, yeah, and the logic, how he uses it. the changelog, great, and some user feedback. Yeah, so it's a, what would you call it, a mature library. It's been around for a little while. Last updated 10 months ago. We're now in October, so at the beginning of 2022. This was last updated at the time of making this video. Okay, I think I've probably whetted your appetite, at least I hope I have, in using this task scheduler. This is certainly accurate enough to be a clock with this task scheduler. So, some options spring to mind there, because I've got a project at the moment on the go for some matrix LEDs, you know, the Max 7219 compact, yet 664 in a little block, 8x8. Well, I've got a 0.9 meter length sitting over there that I'm hoping to use as, would you believe, anyway, I'm going to leave this with you. Comments, queries, suggestions, whatever experiences, please do put them down there. I enjoy reading your comments, and as you know, I answer them all. And if you thought this was mildly entertaining, or you learnt something, or whatever, yeah, give it a hey. That's the one. A like, yeah. And don't forget, if you like these sort of videos, subscribe and ring the bell. It's a two-stage process, I'm afraid. Yeah, we're not going to get around that, so do both. Great, and I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.